All right, we're in section 10.2 where we're going to find arc measures. So, in order for us to be able to find an arc measure, the first thing that we have to do is be able to identify the central angle. All right, central angle is the angle whose vertex is the center of the circle. And I'll show you what that looks like. So if you look at this diagram here, angle ACB, central angle in this case is 50 degrees. All right. From from the central angle, we can look at different arc values. The first one we're going to look at is a minor arc. All right, a minor arc is a part of a circle that measures less than 180 degrees. All right, it's normally written or labeled as two endpoints. So in this case here, arc AB is a minor arc. If we look at uh, the next one, major arc is anything that's in between 180 degrees and 360 degrees. So this is considered a major arc in this particular diagram, and that is going to be labeled with 3 points. In this case, it's going to be A, D, B. That is our major arc in this diagram. All right, and then the final arc measure that we can establish is semicircle. Semicircle is an arc that with endpoints that are of the diameter of a circle, and it measures exactly 180 degrees. So if we go back to this diagram here, it says that the measure of a minor arc is measured at its central angle. Excuse me, I'm sorry. Uh, is measured at central angle. The expression should be the measurement of arc AB. It is read as a measurement of arc AB. The measure of the entire circle, so if you look at the measurement of the entire circle in degrees, is 360 degrees. The measure of a major arc is the difference between 360 degrees and the measure of the related minor arc, all right? The measure of a semicircle is 180 degrees. So if we look at this diagram here, we're looking at the measurement of arc AB. AB comes from the value of that central angle. So since the central angle is 50 degrees, arc AB is also going to be 50 degrees. If we look at arc ADB, what we're going to find out here is it's going to be 360 minus 50 because the whole thing's 360 subtracted by the arc measure of AB, which is 50, and that is 310 degrees. All right, so if we look at the diagram to the right, it says find the measure of each arc of circle C where DF is a diameter. So DF is a diameter, so that should help us. So here, looking at DE is a minor arc. So the measurement of DE is going to come from the central angle, which was measured at DCE, which was 117 degrees. Next, they want us to find DFE. So DFE is a major arc, and all we got to do to find that is take 360, subtract it by 117, so that's where we get 243 degrees. Finally, to find DEF, so DEF, well, DF is a diameter. So since it's a diameter, that means that it's a semicircle. and that means it measures out at 180 degrees. So here they want us to find the measurement of arc RTS and arc TSR from circle P, where ST is the diameter. Okay, so here we got RTS. So RTS is going to be found by taking 360 and subtracting it by 45, and we get 315 degrees. To find TSR, so TSR will be found, well, TS is 180, and that gets added to 45, so that's where we get 225 degrees. This postulate states that the measure of an arc formed by two adjacent arcs is the sum of the measures of the two arcs. So if you look here, it says arc ABC is going to be the sum of AB plus whatever the arc of BC is. So with that in mind, we're going to look at this pie chart, and first things first, they want us to find the arc of BD. So BD is right here, and that comes from taking the values of 105 degrees plus 55 degrees, which equals 160 degrees. Next, they want us to find BAD. So BAD, so that's 140 plus 60, and that's where we get 200 degrees. ADB, ADB, so we're going to have 60 plus 55 plus 105, which then equals 220 degrees. Let me erase some of these. DBC, so I got D, B, so DBC. You could add all these up and take, what, 60 plus 140 plus 105, and it should equal, what, 305, or you could have taken 360 and subtracted by 55 also. Finally, ABC, ABC, and that is, what, 140 plus 105, and that's, what, 245. Circle all those. All right. And then last page here, it talks about having congruent arcs. So to have congruent arcs, two things have to happen. For first thing that has to happen is you have to have the same arc measure. Second thing is you have to have the same radius. So if you look here, BC, arc BC is congruent to arc DE because they're both 75 degrees, and they are the same circle. Since they are the same circle, they have the same radius, so we can say that the measures are going to be equal as well. So yes, these are congruent arcs. If I look over here, arc AB and arc DC have the same measure, but they are not congruent because they are arcs of circles with different radiuses. So these are not congruent arcs. Here we can say that arc GF is congruent to arc JH because they're both 90 degrees, and again they also happen to have the same radii, so they're congruent circles. So we can say that the measurements are going to be equal, so we can say yes, that these two have congruent arcs. And that is being able to find arc measures. Hope this helps. Till next time.